You said draw a triangle?
Yeah, but I don't like that.
Well, can you
Because I was thinking from the origin instead of the starting point.
Ah. No, you have to do it from here, not.
Yeah, I
Not the
can see
triangle.
that now.
All right, now suppose my velocity time graph were that. Let's get some numbers here. Let's make this, we'll make it 10 meters per second. Make that 30 meters per second. And let's make that 10 seconds. What's the displacement here? Meters. Yeah. What generalization can we make between the velocity time graph and displacement?
The total displacement?
It'd be overall displacement, but what?
Wait, repeat the question one more time?
If I give a velocity time graph,
Okay.
what does that tell me about displacement in general? How do I find displacement from a velocity time graph? We're thinking about the answer, Talon.
Would that be like the overall displacement?
Yeah, it is the overall displacement, but if I give a velocity time graph, how can I find the total displacement, overall displacement, or what I generally call displacement?
The slope of it? It's the slope of it, but we already said that.
Velocity is the slope of displacement, but I'm starting with the velocity. How do I get displacement if I know velocity?
You multiply the velocity times the time.
So is that what you did here?
Yeah,
What velocity did you pick?
I did.
It's a
The
change,
change
in
of
velocity.
velocity over time.
Oh,
Yeah,
that
that's
was
what it-
coincidence. No, but change in velocity over time would give you 2 meters per second squared.
Yeah.
Units don't work for displacement.
So this was just my luck.
All right, let's sort of work backwards here. Let's assume a constant acceleration. I have velocity time. I have some initial velocity, I have some final velocity, and I have some time. I know that my displacement is equal to VIT plus 1/2 AT squared.
Yes.
I know acceleration is change in velocity over change in time, so this becomes VIT plus 1/2 VI plus, that's not right, VF minus VI over T times T squared. So acceleration times time squared. That time's going to cancel out with one of those, so I'm left with VIT plus 1/2 VF minus VI times T. So this right here, if I have a rectangle of height VI and a length of T, it's the area of the rectangle. In other words, it's just the area of that rectangle right there. This right here, I have 1/2 times, well, if I have something, a triangle with a height of VF minus VI and a base of T, this is the area of a triangle. 1/2 base times height. Well, that height right there is the difference between VF and VI. My base is T, so this, that second piece, is just the area of that. So my displacement, total displacement, whatever you want, overall displacement, my displacement is just the area under my velocity time graph. So in this problem here, all I have to do is I've got Sue creating a triangle here, I have Lou creating a trapezoid. All I have to do is just equate the areas and figure out what time that works. Questions here before we actually plunge into it? All right, so Sue is part of this triangle here. My base is going to be sometime t, that's what we're trying to figure out. My height is going to be, well, I know that's 0 there. The height's going to be however fast she's going when she gets there. So that is going to be her acceleration times time. So,
Wouldn't it be 60 because it's whenever they meet?
yeah, but Lou's going 60 meters per second, but he had a head start also. So the displacement of Sue is going to be 1/2 Sue's acceleration times time squared. This is the area of the triangle. Lou, on the other hand, I have a triangle and a rectangle, sometime t. I'm going to make the assumption that the time is bigger than 20 seconds. If the time is less than 20 seconds, I'm going to have to recalculate because the rectangle doesn't exist and the triangle is smaller. But this is a height of 60. It has a base of 20. So the displacement, this is for Sue, the displacement of Lou is going to be the triangle 1/2 times 20 times 60 plus the area of this rectangle. Well, my base here is going to be t minus 20. And my height is 60. So it's a matter of when are these two equal to each other. We found her acceleration, no, it's given, 7, that's 7. So I have 3.5 t squared is equal to 600. Oh. One other factor that I've left off. Those are the displacements, but she doesn't, but he has a 300 meter head start. So it's not when their displacements are equal, it's when their positions are equal. So so Lou's position, and I probably should, I'm gonna switch over to X. Lou's position is going to be 300 plus, that is 600 plus 60t minus 1800. And Sue's position is 1/2 times 7 times t squared. That's what I'm gonna say equal to each other. So I have 60t minus 900 is equal to 3.5 t squared. And this quadratic equation, quadratic formula is probably the simplest, unless it factors nicely, and I suspect it doesn't. So I have 3.5t squared minus 60t plus 900 equals 0, and solve. I guess, would you like me to finish it up?
Oh, the answer?
Yeah.
Yeah.
Okay.
I have a question real quick.
Yes.
So when you were finding the triangle for Sue, how did you know that that length was acceleration times time?
I know that the final velocity is equal to the initial velocity plus acceleration times time. The first, basically from the formula of acceleration. The initial velocity for Sue is 0. Right? And so therefore, the final velocity is just AT.
Okay.
So 3.5, negative 60, 900. So 3.5 t squared minus 60 t plus 900 equals 0. Nothing really convenient there. So I have 60 plus or minus the square root of 3600 minus 4 times 3.5 times 900 divided by 7.
It's
63.
unsolvable. Add the plus.
Well, that does not make sense, that it'd be unsolvable.
What plus?
He starts out ahead.
We already did that.
He eventually gets a constant velocity. She just keeps getting faster and faster.
There's an answer. It's just, it's saying that it's undefined.
So I guess what's under the radical is negative. All right, so let's drop back for a second. So Sue starts at rest, and it's Lou who starts 300 meters ahead. Is that right?
Yeah. 1 second.
Yes.
Yeah. Wait, you don't lose the meters ahead of Sue. Yeah.
All right. So Sue they both start at rest. Sue is accelerating constantly until she meets up with Lou.
Yeah.
So that is, and Sue's acceleration is 7 meters per second squared.
Yeah.
All right. So her displacement will be O. Let's see. Because this would be his displacement plus the additional 300, so that seems reasonable. It's a triangle, her displacement 1/2 base times height. Is 1/2.
Did you subtract the 1800?
Yeah, that's how I got
that's
the negative
like
900 here.
Negative 900.
Oh,
What?
what's 6 times 2?
12.
Not 18. So
Oh.
this becomes
No wonder I was
negative 300. That becomes 300.
Dr. Fox, that doesn't do anything. Because
Add the plus, add the plus.
there's nothing. The reason
Yeah, you're
why
right.
it's undefined is because under the radical will be a negative number.
We've already used a chunk.
So
Alright.
why does it matter if it's minus?
Okay, so apparently there's more than one mistake there.
You're trying to figure
Alright, so,
Chill, we're all young.
oh,
This is from all time.
Mm-hmm.
what was the assumption they made?
The assumption you made was, sorry, I have like 5 Blackboard things open. Give me 1 minute. It was something like 9 point.
The assumption they made was that
12.25 seconds. You said it takes her 12.25 seconds to catch up to Lou.
And I made the assumption that it was gonna happen after 20 seconds. And our impossible answer means that assumption was wrong. Now, we happen to make, I made a mistake also, to just complicate matters, but this is fine. His displacement is not, because there's gonna be an overtake sometime in here.
Yeah.
And so,
So would you just do the triangle and then set them equal to each other?
yeah, I would do his triangle, so his triangle. So his position is gonna be 300 plus, well, whatever that time is. The height is going to be acceleration times time, and his acceleration is 3, so that's 3t. So 1/2, 3t squared. And we're gonna set that equal to 1/2, 7t squared. So we have 300 is equal to 2t squared. T becomes the square root of 150, which presumably is 12 point whatever.
Wait, whoa, pause. How did you get that?
If I do away with that assumption that they meet somewhere past here, then the distance or his displacement
Yeah.
after some time t is just the acceleration times however much time has passed, which is, that's his acceleration is 3 meters per second squared
Yeah.
times the time. So this would be his speed when she passes him.
Yeah.
So his displacement is gonna be the area of this triangle.
Yeah.
So that's 1/2 times the base times the height. That's his displacement,
Okay.
plus 300, because he starts ahead 300.
So they both catch up with each other.
Do you want him to like redraw the graph?
Okay, so to find the answer on when Sue catches up with Lou is you do 300 plus the area of the triangle.
For Lou.
But like, how do you know when to stop? Like, we only know to stop it right there because we're making the assumption that the answer is 12.25. If I didn't know the answer, how am I supposed to know that?
Well, the negative under the radical was a big clue that the assumption,
Was wrong?
that our assumption was wrong, my assumption. That, because I assumed it was happened out here when and the negative under the radical meant either it's impossible, which it is, if the time is out here, it is an impossible problem, because she has already gone past him at this point. So if we change that assumption to it happens before 20 seconds is up, that's when we get this.
1/2 3t squared equals 1/2 7.
So her
Oh.
position, that's her displacement or her position, so
Yeah,
she starts
yeah.
here. Okay.
See, that's what I was doing yesterday, but I forgot to do the plus 300. Okay.
Okay.
Yeah, that makes sense. And then, well, there's more questions to that question. Like, after that, it's how far did Sue travel when she caught up with Lou? Which I'm guessing you just find the displacement using the time. So
Yeah.
using 12.25, and then after that, it asks how much time did it take for Sue to cross the finish line? How am I supposed to know what the finish line is?
I did not tell you how long the race was?
No. Not that I see. It doesn't say like a final
One.
time.
No, never mind. I'm wrong.
Then that might be something that I just wrote on the board because I forgot to do it.
Oh,
It was 300 meters ahead, they both start at rest, both start moving, 20 seconds to get to cruising speed. So here a second, touch got below, which one was actually cruised.
the halfway point, so the distance
Oh, there we go.
of them catching up, it would double that. Oh, I'm sorry, I didn't pay attention to that.
So not the one of the ones that I left information off of.
Yeah. Okay.
If like on the test we think that there has been some sort of error made, like you left something off or something, can we like go up and like ask you?
Oh, absolutely. Or in worst case scenario is you make an assumption and just, you know, if you need a value, I left off mass, and you really want a mass, then you can just set mass equal to something, not 0. Okay, move on or ask.
Okay, and then I have another question from the same test. It gives us a question about a car traveling with a constant acceleration of -7 meters per second squared along a straight line, going at a velocity plus 23 meters per second. And then,
I said that was initial velocity?
yes.
Okay.
And basically, well, I knew how to answer the first couple questions, but I got a little confused on letter E, whatever. It says after traveling for the first 6 seconds, what is the distance the car has traveled? Oh wait, no. I knew that answer, didn't
I didn't help.
I? I lied, I didn't know the answer. I lied, I didn't know.
Oh. Yes, I
And
did.
so,
All right, so acceleration was -7 meters per second squared. The initial velocity was positive
mhm,
23 meters per second,
yes,
and time was 10 seconds.
no. 6 seconds. 6 seconds?
6 seconds. And the question is, what is the distance traveled?
Yes.
Well, let's figure out the final velocity. That should give us a big clue. Presumably, that's one of the previous questions. I know the final velocity.
Yeah. But, okay, so the final, so.
Final,
Okay,
go ahead.
okay, so the question before this one is saying what is the car's displacement at 6 seconds?
Right.
Because the car does this, so the displacement is different from the distance.